Good afternoon, everybody. Today's demonstration is on quantum mechanics with the Balmer series of hydrogen. When you look at the energy levels of an atom and you have an electron in an excited state, when it goes from one state down to another state, you will emit a certain energy photon. For the hydrogen atom, if you go from the n equals 3 to the n equals 2 transition, you will get a red line that is known as the H alpha line for the spectrum, for the emission spectrum of hydrogen, that is at 65-63 angstroms. The next line is kind of a bluish green line that is called the H beta line. If you do a quantum mechanical transition from the n equals 4 state to the n equals 2 state, then you get the blue-green line at 48-61 angstroms. The next line is the H gamma line at 43-42 angstroms. This one you make the transition from the n equals 5 level to the n equals 2 level in the hydrogen atom. That is a violet line. And in the last line we will look at is the H delta line at 4101 angstroms. That is when you have a transition in the hydrogen atom of the electron going from the n equals 6 excited state down to the n equals 2 excited state. These transitions give photons of visible light. That is why we can demonstrate this. I will now move the camera. If you notice, I have an apparatus. It is simply a little diffractometer that you can change the angle. There is a diffraction grating on this stand over here. There is a movable lens that I can move this lens back and forth. And here, if you look over here, here is a high voltage source with a hydrogen gas discharge tube connected right here. So my finger is pointing at the gas discharge tube. When I turn this on, you may hear a little humming. Now there's light shining from that discharge tube. You can see that little glow. Okay, I'll bring the camera to the lens and I will first move this around. If you look at this, here is just simply a magnified view of that. You should see this kind of a pinkish line in the view of the camera in that little lens. Okay, what we're going to do now is we're going to go through these lines one by one, and of course different wavelengths of light will diffract differently in this diffraction grating. So now we will go to the red line. I will move this away, and then I have to look here and move this. So now I have the red line. You notice it's at an angle. I will bring the camera so you can see that. Now you can see that is known as the H alpha line. It's kind of a reddish color. The sun emits this color of light in its chromosphere. If you take a special filter and a telescope, you will see this color of glow coming from the sun. So that is the H alpha line at 65-63 angstroms. These transitions correspond for the n equals 3 down to the n equals 2 quantum level in the hydrogen atom. Okay, the next line we're going to do is we will go to the H beta line. Here you should see kind of an aqua color line. It'll look sort of bluish here in the camera. And there it is. It's kind of a light blue aqua green color. There's the beta line, and the transitions correspond for n equals 4 to n equals 2 quantum states in the atom. And remember, this is an emission line spectrum. This corresponds to the electricity in this device is exciting the hydrogen atoms in the gas, and then they go from the excited state down to this lower excited state to give these visible photons we can see. Okay, the next one we will do, we'll be able to see the next one. It is called the H gamma line. So I need to move this. Okay, it's easy to see with the eye. Let's see if the camera can pick that up. Yes, it can. You can see this. Okay, the camera is picking it up with its sensitivity. It's sort of a blue color that is really a violet, a nice deep violet color. That is the H gamma line at 43, 42 angstroms. So we're going from the n equal 5 to the n equal 2 quantum state with this visible light. So it's a violet light. The camera is making it look sort of bluish color. Okay, now let's see. It's very hard to even see the next line. Now we'll see if I can find it. Okay, I can barely see it. It may be too close to the other line to pick up. Yes, the camera can actually get it. If you see that, you can see that faint violet bluish glow in there. The camera is actually able to pick up the H delta line at 4101 angstroms. These correspond to the jump from the n equals 6 quantum state down to the n equal 2 quantum state. So this is another violet line. So it was actually able to be viewed on the camera. Good afternoon, everybody. Today's demonstration is on emission line spectra. For emission line spectrum to occur for an element, you need to have it in a gaseous state. And here, this device, I will show this. Here I got this diffractometer with a diffraction grating. There's the diffraction grating right here. Here is a movable lens. You can move this back and forth. And here I got another lens that is connected here by this gas discharge device here. This gives thousands of volts. And here the neon gas is in this tube, and it will glow once the switch is activated. So when you excite the gas in this tube, the electrons go to a higher energy state because of the energy of the electricity pumping energy into the atoms in the neon gas. Then, of course, after a short time, which is very short, the atoms have their electrons jump to a lower energy state, emitting a photon. Here we will be able to see lots of photons being emitted in the emission line spectrum. So now what I'll do is I will turn on the tube, and you should see that nice red glow. This is the same gas that they use when you see the neon signs on various businesses in the evening, especially in town. So now I'll move this. Here I have this where you'll just simply see the red color in the lens. That's just aiming straight on to the gas discharge tube. What I will do now is move this lens. So now I need to just move this away. If you look here, you should be able to see a faint green color. Let me see if I can get this adjusted correctly. It's kind of hard to see that. Okay, there, I got it. You should see that faint green line. There's a couple of green spectral lines for these. So the color of light of these photons reaching this camera is green. So it would be in the green part of the electromagnetic spectrum of visible light. Now if I move this lens over a little more, so you can see those, there's two green lines are faint. Now if I move this more, you will see a yellow line and a bunch of orange lines together. And it may be a little tricky seeing this in the camera. There's a yellow line here, and if I move this a little more over here, you can see orange lines. So yellow line here, and there's some orange lines, and there's many lines next to each other corresponding to different energy level transitions for the excited electrons in the neon gas atoms. and I will move it more on this angle. Here you should be able to see orange lines and red lines. There's many lines close by to each other in the spectrum. So you notice when we looked at the spectrum, there was a couple of faint green lines for the higher energy photons, but as you can tell by the color of the gas from the discharge tube, that the transitions are yellow, orange, and red, making this nice reddish orange glow in the neon gas tube. And you notice when you look at these emission line spectra, even if an element has a relatively low atomic number, you can still have many spectral lines, as neon gas demonstrates. There's many visible spectral lines for the excited electrons in neon gas.